Good morning. We have completed till question number 20 of exercise 13.1 using the concepts of limit. Now today we are going to start with 21st example. Given over here is limit x tends to 0 cosec x minus cot x. Now if we directly keep the value here as x, then it will be undefined. X as 0, then it will become undefined. So directly we cannot keep x as 0. So we'll convert them in terms of sine and cos. Now why we need to convert them in terms of sine and cos? Reason, the standard limits are in terms of sine and cos. So in the place of cosec x, writing 1 by sin x, cot is cos upon sine. So combining both, we'll get 1 minus cos x upon sin x. And as x is tending to 0, if we directly keep x as 0, then it will become 0 upon 0. So we cannot keep x as 0 directly. Now we will make use of the formulas. Cos 2x is 1 minus 2 sine square x. These all formulas you have done in chapter 3, trigonometric functions. Shifting 2 sine square the other side and cos 2x towards RHS, we get 2 sine square x is equal to 1 minus cos 2x. So if 2x is there, then we get x here. If x will be there, we will get x by 2. That is, we have to make half. So for 1 minus cos x, we have the value 2 sine square x by 2 using the formula of cos 2x. So in the place of 1 minus cos x, keeping 2 sine square x by 2. Now sin 2x formula is 2 sin x cos x. So the formula of sin x will be 2 sin x by 2 cos x by 2. So in the place of sin x, keeping 2 sin x by 2 cos x by 2. Cancellation of 2 takes place and 1 sin x by 2 gets cancelled. So the remaining terms are sin x by 2 divided by cos x by 2. Now this cannot be simplified further, so we will be keeping now in the place of x as 0. So it becomes sin 0 divided by cos 0. The value of sin 0 is 0 and the value of cos 0 is 1. So 0 divided by 1, the answer is 0. Here we have to make use of the formulas of multiple and submultiple forms, which is being covered in chapter 3, trigonometric functions. 22nd example. Given is limit x tends to pi by 2 tan 2x divided by x minus pi by 2. Now whenever we come across with pi by 2 minus x, pi minus x, 3 pi by 2 plus x or minus x, 2 pi, that means if the radian measure is there or if it is expressed in terms of pi, then taking up the assumption method becomes easy. So taking up x minus pi by 2 as alpha, the value of x will become alpha plus pi by 2, because minus pi by 2 shifted the other side becomes pi by 2 plus alpha. Now as x is converted in terms of alpha, the limits will also change. X tends to pi by 2. Now keeping here x as pi by 2, we'll get it pi by 2 minus pi by 2 as 0. So if x is tending to pi by 2, alpha will tend to 0. Now changing all x in terms of alpha, we'll get limit alpha tends to 0, 10, 2 is kept as it is, and x is replaced by pi by 2 plus alpha whole divided by alpha. So we get limit alpha tends to 0, 10, multiplying 2 inside with both this, we'll get it as 2 pi by 2 plus 2 alpha. 2 and 2 gets cancelled. So it becomes 10 pi plus 2 alpha. Now pi plus 2 alpha will be lying in third quadrant, and in third quadrant 10 is positive. So we will get 10 to alpha divided by alpha. Now to use the formula, that is 10x upon x equal to 1 when alpha tends to 0 or x tends to 0, we have here 10 to alpha and in denominator only alpha is there. To bring 2 alpha there, we'll multiply as well as divide by 2. So we'll get here 2 10 to alpha divided by 2 alpha. Now 10 to alpha divided by 2 alpha will be equal to 1 because alpha is tending to 0. So 2 into 1, the answer is 2. 23rd example is find limit x tends to 0 fx and limit x tends to 1 fx where fx is equal to 2x plus 3 when x is less than or equal to 0 and 3 into x plus 1 when x is greater than 0. Now we'll calculate the first part, that is limit x tends to 0 fx. Now limit x tends to 0 fx, we have to take the first function, that is 2x plus 3, because it is given here equal to 0. So the first function is having equal to 0. That is the reason that is to be taken up for x tending to 0. Keeping the value of x as 0, 2 into 0 plus 3 will give you 0 plus 3, and the answer is 3 when limit x tends to 0. Now if we take limit x tends to 1 of fx, now as 1 is greater than 0, so we have to take the second function 3x plus 1, because given over here x is greater than 0 and 1 is greater than 0. So taking up 3x plus 1, keeping the value of x as 1 and calculating it, the answer is 6. 24th one is find limit x tends to 1 fx where fx is equal to x square minus 1 when x is less than or equal to 1, minus x square minus 1 when x is greater than 1. Now here in this example we will be taking the left hand side and the right hand side limits of 1, that is x tending to 1 minus and x tending to 1 plus. If in both the cases answer is same, then the limit x tends to 1 of fx will exist. If both gives different answer, then limit will not exist. So beginning with limit x tends to 1 minus of fx, that is equal to limit x tends to 1 minus. Which fx we have to consider? When 1 minus is there, then x will become less than 1. So x less than 1 means fx x square minus 1 is to be selected. Keeping the value of x as 1, we get the answer as 0. Now the same fx we have to take for x equal to 1. Reason is equality sign is there. So keeping the value of x as 1, we will take x square minus 1 as a function. In the place of x keeping 1 and calculating, it becomes 0. Now going for the second part, that is limit x tends to 1 plus. That means x is approaching 1 from right of fx is equal to limit x tends to 1 plus. Now if x is approaching from right, that means the value of x will be greater than 1. So when x is greater than 1, the function becomes minus x square minus 1. So taking up the function minus x square minus 1, keeping the value of x as 1, we get minus 1 square minus 1, and calculating it, we get the value of limit as minus 2. Now if we compare all these three limits, they are not same. So it is being expressed as limit x tends to 1 minus of fx is not equal to limit x tends to 1 plus of fx, and it is not equal to f of 1. As all these three are not equal, the limit will not exist. and if they are equal, the limit will exist. So for the existence of limit, it is compulsory that from the left and from the right, the answer should be same. Example number 25th. Given is evaluate limit x tends to 0 fx, where fx is equal to mod of x divided by x when x is not equal to 0 and equal to 0 when x is equal to 0. Now as two functions are given here, we'll be going for 0 minus, 0 plus, as well as x equal to 0. Taking up limit x tends to 0 minus of fx, keeping fx as mod of x divided by x. Now here we will be considering the first function, that is mod x divided by x, both for 0 minus as well as 0 plus. And 0 will be considered only for the value of x is equal to 0, that is f0 will be equal to 0. Now as we have taken limit x tends to 0 minus, that means x is approaching from left of 0. Now left of 0 all the numbers are negative. So when we open the mode, we have to keep a negative sign for 0 minus. So we get here minus x divided by x, that will be equal to minus 1. Same with limit x tends to 0 plus fx. Here also fx will be taken the same, because second one is only when it is equal. Keeping the value of fx as mod x by x. Now as x is approaching from right of 0, the right side of 0 is always positive. So if we remove mod, it becomes a positive x divided by x, the answer is 1. Now if we compare all the three answers, that is for 0 minus, 0 plus and 0, then all the three answers are different and they are not equal. And if they are not equal, limit will not exist. So here limit does not exist.